Hello and welcome to Physics Teacher. Join me as I tackle this grade 12 chemistry contest problem from Waterloo University to see how we crack it. Alright, so this problem is specifically from Thermodynamics, and it's the physical changes in the Thermodynamics unit for grade 12 chemistry. So here we have a 100 milliliter sample of water at 90 degrees. And we are going to mix it with a 200 milliliter sample of water at 10 degrees. And it wants to know what is the value of the temperature after they're mixed, assuming no heat is lost to the surroundings. So to solve this, we're going to use our equation that the heat gained by one sample of water plus the heat lost by the other sample of water must be equal to 0. Again, this is true if no heat is lost to the surroundings. So the water that gains heat is going to be the one that's initially at 10 degrees. It's the one that's going to warm up when we add it to water at 90 degrees. So that is I'll call it 1. That'll be our sample 1. So M1C1 delta T1 plus our 100 milliliter sample, I'll call that 2. Will be M2C2 delta T2. That's equal to 0. Now in this case, both samples are water. So the value for the specific heat capacity, which they give us, we actually don't need because we can divide every term by C and they will cancel. But be careful, you can only do this when the substance is the same thing. If you're mixing water with something else, like ethylene glycol, then no, the values are different. You can't do that. All right, so mass 1. Now, it doesn't directly give us mass. It tells us 200 milliliters, but it's saying use density for water as 1 gram per milliliter. So that would be equivalent to 200 grams. Now, the change in temperature is always final minus initial. But we don't know what that final temperature is. That's what we're looking for. And its initial temperature was 10 degrees Celsius. Now our other sample is 100 milliliters. So using density, that's 100 grams. Now this is the one that's losing heat. It's initially at 90 degrees. When we mix it with 10 degree water, it's going to lose heat. So again, we don't know its final temperature, but it'll be the same final temperature over here. So those two variables are the same, minus its initial temperature of 90 degrees Celsius, and that'll equal 0. All right, so now we have our equation all set up. We just have to rearrange and solve for final temperature. So we're going to start by expanding each set of brackets. So this first set will be 200 grams times final temperature, minus 200 times 10, so 2,000 grams degrees Celsius. Plus, here we have 100 grams times final temperature, minus 9,000, so 90 times 100 grams degrees Celsius is equal to 0. So now collect like terms. So minus 2,000 and minus 9,000 is minus 11,000. And if we bring it to the other side of the equation, it'll be positive 11,000 grams degrees Celsius. And then we have 200 TF and 100 TF. So when we add those together, we get 300 times final temperature. So now if we divide both sides by 300 grams, you can see our units will work out. So grams cancel. And we're left with degrees Celsius, specifically 37 degrees Celsius. So it says choose the closest value. That closest value would be A. Well, I hope that video helped. And if you're planning this year on writing either the grade 11 or 12 Waterloo Chem contests or the Syn Physics contest for Waterloo, check out my playlist on my channel because I got lots more practice problems and more coming.